Welcome to the Four Men in a Basement podcast. Today, we will be discussing the history of the atom. So, I did a little bit of research on two early philosophers who were actually the first two to contribute to the atomic theory. Those two men were Democritus and Aristotle. Democritus was born in 460 BC in Abdera, Thrace, and died in 370 BC. He was a pre-Socratic philosopher who was also quite intrigued with science. It isn't known when he came up with his theory, but he called it Democritus's atomic theory. Seems kind of cocky in my opinion.
I would agree.
It stated that the universe and all forms of matter obey the same principles. Everything is composed of atoms, which are physically but not geometrically unable to be divided. Between atoms there lies empty space, and atoms are unable to be destroyed. Aristotle was a Greek philosopher. He was born in 384 BC and died in 322 BC. Although his main focus was philosophy, Aristotle obviously did some scientific work, and some that impacted the way things were seen for centuries after. Around 360 BC, he came up with a theory that there were five elements: air, which was light; earth, which was cool and heavy; water, which was wet; fire, which was hot; and aether, which was his explanation of divinity and the stars above.
You're saying water's wet?
I guess so. This was later proven wrong when other elements were discovered, but it was pretty widely accepted up until the 17th century or so.
So, I was reading about this fellow, John Dalton. He was born September 6, 1766. In 1803, he created the first chart of atomic weights and believed that elements could be distinguished by their weight alone. The same year, he put forward his atomic model, which was the invisible solid sphere model. He hypothesized that an atom is a solid sphere that cannot be divided into smaller particles. So, does anybody else have something to talk about?
I actually do.
Oh, so nobody else then. Great, because I have another. Eugen Goldstein was this guy born in 1850. In 1866, he discovered that tubes with perforated cathode also emit a glow at the cathode end. He later recognized as electrons moving from the negatively charged cathode towards positively charged anode, there's another ray that travels in the opposite direction. He called these canal rays. Because of his observations, he is sometimes noted with the discovery of the proton, and he greatly increased the understanding of the atom.
Very good. For my first scientist, I chose to read up on Joseph John Thomson, or JJ for short. Today, he's most well known for his conduction of the cathode ray tube experiment, which he did in 1897. During that experiment, what he used was obviously a cathode ray tube, which is a vacuum tube with two electrodes on one side. One of them is positively charged, and one of them is negatively charged. And that allowed him to emit a beam of light through the tube. And along the tube, he placed magnets that held opposite charges. And once the beam of light reached those two magnets, it bent, so to speak, towards one of the particular magnets. In this case, it was the positive magnet, and from there he was able to deduce that the beam was composed of negatively charged particles. And then another notable thing that he did was 7 years later, in 1904, where he developed his plum pudding model, which is what he believed atoms were made up of the time, and this was primarily a model containing several electrons occupying one specific space.
Interesting. So I read about another guy, and the last guy that I read about was Robert Millikan. He was born on March 22nd, 1868, and died on December 19th, 1953. He was an American experimental physicist. His biggest success, though, was in 1910, and it was figuring out how to accurately measure the charge carried by an electron. It was later known as the oil drop experiment. The oil drop experiment demonstrated the atomic structure of electricity. He did this by using his own method, which he called the falling drop method. He dropped tiny charged oil droplets in between two parallel metal plates which formed a capacitor. The atomized oil droplets were ionized by an X-ray, which made them negatively charged. He then measured the velocity, mass, gravitational force, and then compared it to the known density of the falling oil drops without an applied electrical field as his base measurement. He then tested the drops with an applied electrical field, which he then adjusted until the field was strong enough to suspend the drops because the field was equal to the gravitational pull. After that, he was able to measure the charge of the electrical field and then was able to determine how much charge was in each electron.
Very interesting. And with that, we cut to our break. We will be back with the second half of our scientists. Thank you very much. And we're back with the second half of our scientists. Thank you for staying tuned in.
I researched Ernest Rutherford. Yeah, research, Marshall. Wow. Yeah, I researched Ernest Rutherford, and all I can say is, wow, what a man. His first contribution towards the atomic model was in an experiment when he was studying uranium and radiation emitting from it. He named them alpha and beta. From this, he was able to estimate atom size and that mass is concentrated in the nucleus of the atom. Later in 1911, Rutherford conducted the gold foil experiment. In the experiment, Rutherford took a thin piece of gold foil and used the alpha particles as atomic balls to shoot at the gold foil. What happened, though, was some alpha particles were deflected back at the alpha particle emitter and off the sides to the detecting screen. The detecting screen would glow every time it was struck by a alpha particle. From this, he was able to conclude that there was a small, dense, positively charged nucleus in the atom, and he assumed the electrons were outside the nucleus. With these new changes, he came up with the Rutherford nuclear model. This showed the atom as a small, positively charged nucleus with protons that orbit around the nucleus. However, in the model, there is no set path for electrons to move.
Wow, that was quite interesting, Marshall. For my second scientist, I chose to research a man by the name of Niels Bohr. He was born in Copenhagen, Denmark on October 7th, 1885. Today, he's most often known for his creation of the Bohr model, otherwise known as the planetary model, which he made in 1913. As you can see in this model, there is a positively charged nucleus in the center, surrounded by multiple rings or orbits of electrons, similar to how the sun is orbited by multiple planets. And in this instance, the electrons that orbited the nucleus were believed to be able to move between the rings, and in doing so would give off or absorb energy depending on the transition that was given.
My next scientist I researched was Louis de Broglie. He was an eminent French physicist. He gained worldwide acclaim for his groundbreaking work on quantum theory. In his 1924 thesis, he discovered the wave nature of electrons and suggested that all matter have wave properties. And for my final scientist, I researched Erwin Schrödinger, and in 1926, Schrödinger, an Austrian physicist, took the Bohr atom model one step further. Schrödinger used mathematical equations to describe the likelihood of finding an electron in a certain position. The atomic model is known as the electron cloud model, or also known as the quantum mechanical model of the atom. The difference between the planetary model and the electron cloud model is that the electron model does not define the path of the electrons. It predicts where the location of the electron could be. The model looks like a nucleus with a cloud of electrons around it.
For my final scientist, I chose to research James Chadwick. He was born in Cheshire, England, on October 20th, 1891. In 1932, he made a massive discovery regarding the structure of the atom, and most specifically the neutron. He was able to discover this when he was bombarding beryllium with alpha particles, and in turn found that it gave off a radiation that was he classified as neither positive nor negative. This eventually led him to the development of the atom bomb, along with the fission of uranium-235.
Interesting.
I thought so. I thought that was very interesting.
All those science is really interesting.
That it is. Thank you for watching this podcast. Be sure to tune in next time.
Wait, was I supposed to be recording this?